Welcome to All About Science, Space and Technology. If you love discovering the mysteries of the universe, you're in the right place. Today we're diving into some unbelievable space facts that will absolutely blow your mind. Get ready to explore the incredible. Have you ever looked up at the night sky and felt a sense of wonder, a curiosity about what secrets the universe holds? Well, get ready to have your mind blown, because we're about to explore a planet so extravagant, so over the top, it makes diamonds look like basic table salt. I'm talking about 55 Cancri e, a planet twice the size of Earth, located about 40 light-years away in the constellation Cancer. Now what makes this planet so special? It's literally made of diamonds. You see, 55 Cancri e orbits a star, much like our sun. But here's the kicker, this star is incredibly rich in carbon. And when I say rich, I mean filthy rich. Now this carbon, under the extreme pressure and heat deep within the planet, has been compressed into a giant, sparkling diamond. We're talking a bling factor that would make even the most extravagant rapper blush. Imagine a celestial body twice the size of our home planet, glinting under the light of its parent star, a cosmic diamond so massive it would be worth, well, let's just say more than the entire GDP of Earth. And to think, this isn't some science fiction fantasy, it's a reality out there in the vast expanse of space. But here's the thing about space exploration, my friends, it's not just about discovering the extraordinary, it's about pushing the boundaries of what we think is possible. This diamond planet, it challenges our understanding of planetary formation, it makes us rethink the very building blocks of the universe. Think about it, if we can find a planet made of diamonds, what other mind-boggling wonders await us out there? Neutron stars denser than 1 billion elephants crammed into a teaspoon? Black holes that warp space and time, bending the very fabric of reality? The universe is full of surprises, and that's the beauty of it. So, the next time you look up at the night sky, remember 55 Cancri e, a testament to the universe's extravagant nature, and a reminder that the cosmos is full of possibilities beyond our wildest imagination. And who knows, maybe one day we'll be mining diamonds among the stars. You know, when we think about the coldest places in the universe, our minds often wander to the vast, empty spaces between galaxies, right? I mean, it makes sense, right? But what if I told you that the coldest place ever recorded isn't billions of light years away, but right here on Earth in a laboratory? You heard that right, folks. Colder than the void of space, colder than the echo of the Big Bang. We're talking about a temperature so low it's practically inconceivable, 1/2 of 1/1000th of a degree above absolute zero. That's 0.000000005 Kelvin, for those of you keeping score at home. Now to put that in perspective, absolute zero, which is minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit, is the theoretical point where all molecular motion stops. Everything freezes, even time itself slows to a crawl. Now this record-breaking chill was achieved by a team of brilliant minds at MIT, and they did it by using lasers to slow down atoms. You see, temperature is really just a measure of how much atoms are jiggling around. The hotter something is, the faster its atoms move, the colder it is, the slower they go. So, these scientists used lasers to essentially create a kind of optical molasses that trapped these atoms and slowed them down to a virtual standstill. And boom, just like that, they achieved the coldest temperature ever recorded, right here on our little blue planet. Now you might be thinking, okay, that's cool and all, but what's the big deal about a bunch of super cold atoms? Well, here's where things get really interesting. You see, at these ultra-low temperatures, matter starts to behave in some really weird and wonderful ways. We're talking about quantum mechanics on a macroscopic scale, where the rules of classical physics no longer apply. For example, at these temperatures, atoms can start to act like waves instead of particles, a phenomenon known as Bose-Einstein condensation. They can also become superfluid, meaning they can flow without any resistance, defying gravity and climbing the walls of their containers. It's like something out of a science fiction movie, but it's happening right here in the lab. Chapter 3, Venus, where time gets twisted. Let's take a trip to our neighbor Venus, often called Earth's twin because of its similar size and composition. But don't let that fool you. Venus is a planet of extremes, with a runaway greenhouse effect that would make even the most hardcore sauna enthusiast sweat. But we're not here to talk about the heat. We're talking about time, specifically how time gets warped on this bizarre and beautiful planet. You see, on Venus, a day is longer than a year. That's right, you heard me correctly. It takes Venus longer to rotate once on its axis than it does to complete an orbit around the Sun. We're talking about a day that lasts a grueling 243 Earth days, while a year on Venus is a relatively brisk 225 Earth days. Now imagine trying to set your watch by that. Talk about a messed up sleep schedule. But seriously folks, this bizarre phenomenon is due to Venus's incredibly slow rotation and its retrograde orbit, meaning it spins in the opposite direction to most planets in our solar system. Now this isn't just some random cosmic quirk. It has profound implications for how we understand planetary dynamics and the evolution of solar systems. For example, it challenges our understanding of how planets form and why some planets rotate in the opposite direction to their stars. Chapter 4. The Sound of Silence? In Space? Alright, let's address the elephant in the room, or rather the lack of sound in the vacuum of space. You know the dramatic scenes in sci-fi movies where spaceships explode with deafening roars? Yeah, that's Hollywood taking some creative liberties, to say the least. Here's the deal, sound, as we know it, is a vibration that travels through a medium, like air or water. It's how we hear those sweet, sweet tunes or the annoying drone of a mosquito. But in the vacuum of space there's no air, no medium for those sound waves to travel through. It's the ultimate silent disco, except there's no music, just the eerie silence of the cosmos. But hold on, before you think space is a completely silent void, let me clarify something. While we can't hear sound in the traditional sense in space, it doesn't mean there aren't any vibrations out there. In fact, space is teeming with electromagnetic radiation from radio waves to gamma rays, and these waves carry energy, just like sound waves. Now what scientists do is use specialized instruments to capture these electromagnetic waves and then translate them into sound waves that we can hear. It's like giving the universe a voice, and trust me, it has some pretty wild stories to tell. For example, did you know that black holes, those cosmic monsters that devour everything in their path, actually emit a low hum? It's true. Scientists have been able to capture these gravitational waves, ripples in the fabric of space-time itself, and convert them into sound, and it's one of the most haunting and awe-inspiring sounds you'll ever hear. Chapter 5: Neutron Stars, the ultimate cosmic heavyweights. Alright folks, get ready to have your minds blown because we're about to dive into the world of neutron stars, the densest objects in the known universe. These cosmic heavyweights are the remnants of massive stars that have gone supernova, exploding in a blaze of glory and leaving behind an incredibly dense core. Now, imagine this. A teaspoonful of neutron star material would weigh as much as Mount Everest. That's like cramming the entire Himalayan mountain range into a teaspoon. The density is so extreme that atoms themselves are crushed, their protons and electrons forced to merge into neutrons, hence the name neutron star. To give you an idea of just how mind-bogglingly dense these objects are, consider this. If you were to drop a marshmallow onto the surface of a neutron star, it would hit with the force of 1,000 hydrogen bombs. That's some serious impact. Now you might be thinking, okay, that's pretty extreme, but what's so special about these neutron stars? Well, for starters, they're like giant cosmic laboratories that allow us to study physics in conditions that we could never replicate here on Earth. For example, the gravity on the surface of a neutron star is so strong that it warps the fabric of space-time, causing light to bend around it. This phenomenon, known as gravitational lensing, allows us to study objects that are hidden behind the neutron star, like a cosmic magnifying glass. The universe is full of wonders and we've just scratched the surface. Which of these facts blew your mind the most? Let us know in the comments below. If you enjoyed this video, don't forget to hit that like button, share with your fellow space enthusiasts, and subscribe to All About Science, Space and Technology for more mind-bending content. See you in the next video.